In this tutorial, we are going to talk about creating a simple mechanical training in SimLab Composer using the Training Builder tool. The goal of the training would be to install a fan on the pump, then assemble the cover and secure. Before we begin, let's take a look at the Training Builder tool first, which can be accessed from the Virtual Reality Workbench. Inside the Training Builder, you will find an assortment of buttons arranged by their type into Inputs, Events, Responses, and Booleans. Under Inputs, you would find the sources for the events. These are the nodes that connect elements in the scene to events which allow responses to be consequently executed. Some of the input nodes are sequences, scene states, scene nodes, to name a few. Under Events are the nodes that can register interactions in the VR experience and then issue a command to execute a response. Click on the Node Entered Node Event button. An event block will appear with two channels to the left. Through these channels, we will determine the scene modes, which upon their intersection, a response will occur. Click on the Scene node under Inputs to create a scene node block. Attach the scene node to the first channel in the event block by dragging the red output connector. Use the scroll to zoom in and out and press and hold the wheel to pan the view. Now select an object from the scene and click on the Attach button in the Scene node block. The Attach button determines which 3D object to be introduced to the event block. Create another Scene node block by either clicking the button under Inputs or dragging it to the scene to determine its position according to the location of the cursor. Select a different object from the scene and attach it to the second input node. Then attach the node to the second channel of the Node Entered Node event block. What we have now is an event that can elicit a response once the first scene node collides or enters the second scene node. To complete the chain, we would need to attach a response to the Execute channel of the event node. Some of the responses are Apply Scene State, Play Sequence, Stop Sequence, Glow and Unglow an Object, among other available responses. Let's create a Change Grabbable State response for this example. Now, to determine which node we are modifying the grabbing state for, we need an Input Scene node. Add one from the input ribbons, then attach an object to it, and then connect it to the Response node. Now connect the Execute channel from the event to its corresponding channel in the Response node. What we have created is a simple event system, where once the 3D object named Bolt2 enters the 3D object named Cover, the 3D object Fan becomes ungrabbable, and the user can no longer interact with it. Delete the created nodes by selecting them and pressing the Delete key on your keyboard, and let us proceed with the creation of the mechanical training. The pump model on which we are going to create a mechanical training for is in its assembled state, which we can use to our advantage and capture this state using the Scene States tool and use to build the training. Hold Shift and double-click the cover part to select its group, and from the Scene State menu select Capture. Toggle off all the attributes except for the Transformation attribute and click on Capture from Selection. As you can see in the bottom panel under Scene States, a new item was created with an image of the selected cover part. This item contains the transformation attributes of the cover at the moment of capturing the scene state. So if we were to change the location of the cover, applying the scene state would revert it back to its captured transformation state, and that technique would be the foundation of this training. With the cover selected, press H on your keyboard to hide it and reveal what is underneath it. Let us capture scene states for all the parts that are involved in the fan installation process. Select the first bolt holding the cover and from the Scene States dialog, select Capture from Selection. Go through the bolts one by one, creating a separate scene state for each so that we can handle them later individually. Create a scene state for the fan as well as the washer and bolt holding it in place. Select the first created scene state and name it Cover Placed. Select the second scene state and name it Bolt 1 Placed. Having a clear naming convention for scene states and sequences eases the process of utilizing them in the training builder greatly. Continue naming all of the remaining scene states. To show the cover part again, select it from the object tree to the left and press S on your keyboard. Aside from creating the scene states which are essential to create the training, we can create animation sequences that might not be necessary to have, but can add a visual appeal to the interaction with components. Select the screwdriver's highest second level of its assembly by holding Shift and double-clicking the screwdriver 2 times, or by selecting the assembly named Screwdriver from the object tree. Switch to the Animation tab and set the current keyframe to frame 30. Then rotate the screwdriver clockwise 90 degrees. Set the current frame to 60 and rotate it 90 more degrees in the same direction. Set 2 additional keys at frame 90 and 120 with a 90 degrees increment in rotation to complete a 360 degrees rotation animation. Now select the created keyframe and click on the Create Animation Sequence button. Type in the name Driver Clockwise, and remember that has an option to create a reversed animation by toggling the Create Reverse option if you have a use for a counterclockwise animation. Click OK to finish the sequence creation process, and if you switch the bottom panel to the Sequences tab, you will find the created animation sequences there. Select a bolt and create a rotating animation for it similar to the screwdriver's animation. Set the current frame to 30 and rotate the bolt 90 degrees and push it slightly inwards. Then set the current frame to 90 and rotate it 90 degrees and push it inwards once more. And continue to do so to get to frame 120, mimicking the animation of a bolt tightening. Now select the keyframes and create an animation sequence, then type in a name related to the bolt you animated, and in our case it was Bolt 4. Follow the same steps to create animation sequences for the remaining 3 bolts holding the cover. Once we have created scene states and animation sequences for all the components involved in the training, we can begin to scatter the components to their intended initial form in the training. Select a component, then press N on your keyboard, then click on the surface of the workbench to snap the object to it. Now that the scene's preparations are complete, click on the Training Builder icon. Create a Node Entered Node event. The first step in the training is to place the fan on the rotating shaft in the pump. So, with the fan selected, create a scene node input and then click Attach. Create another scene node input and attach the shaft to it. And now connect both scene nodes to the event node channels. Create a scene state response and attach it to the event. Then from the Scene States panel, drag and drop the fan-placed scene state onto the Training Builder. Then attach it as the input for the response. What we have created in an event where the fan touches the shaft, the scene state named Fan in Place would be applied, positioning the fan at the shaft correctly. Before we proceed, let us pick the fan's assembly and from the Actions menu, select Make Grabbable. The assembly's icon is changed in the object tree, indicating that this object can now be grabbed and moved by the user during the VR experience. To test the scene out, from the Viewer menu, select Show in Viewer. Then select Desktop Mode or VR Mode if you have a virtual reality device. Press H on your keyboard to reveal the hand, then aim towards the fan and use the mouse wheel to extend your reach. Notice that the fan was highlighted upon the hand reaching it, indicating that it is a grabbable object and can be moved. With the hand intersecting the fan, click and hold the left mouse button, and move the mouse towards the rotating shaft. Once the fan touches the shaft, the scene state is applied, and the fan is positioned at the right place and the grabbing ends. Go back to the Training Builder and create a Change Grabbable State response. Connect this response to the created event, then connect the fan's input node to the response, and make sure that the grabbing state is set to false. By establishing this connection, we are telling the Training Builder to make the fan ungrabbable once it is placed inside the pump. When the trainee places the fan, the following step for him would be to place the washer on the fan. Select the washer from the 3D area or the object tree. Then create a scene node input and attach it to it. Then create a Change Grabbable State response and connect it to the event and to the washer's input node and change its state to True. Now that the trainee can grab and move the washer, we need to create an event to position the washer on the fan. Create a Node Entered Node event and connect the washer to its first channel. Then add a scene node input, attach the fan to it, and connect it to the second event's channel. Create a scene state response and connect it to the event's execution channel. Attach the washer-placed scene state to the recently created response. And similar to what we did with the fan, we are going to make the washer ungrabbable once it is placed on the fan using the Change Grabbable State response. Attach the previously used washer's node to the response, or select it and press Ctrl and C, then Ctrl and V on your keyboard to duplicate it, and connect the duplicate to the response to avoid cluttering the training builder's view. Proceeding with the chain of events, we now need to make the main bolt holding the fan movable once the washer is in place. Create a Change Grabbable State response. Then select the main bolt and add it as an input. Then connect it to the response while making sure the response's state is set to true. Run the viewer to test the progress made so far. Create a Node-Entered-Node event to place the main bolt. Connect the main bolt to the first channel and the fan to the second channel. Add a scene state response and connect it to the event. Then add the scene state named Main Bolt Placed to the training builder and connect it to the response. Create another Change Grabbable State response and attach the screwdriver to it and set its state to true. The chain we have so far is that once the main bolt collides with the fan, it's going to be placed on it, and the screwdriver will become grabbable. To create an event where the screwdriver tightens the bolt, add a Node-Entered-Node event, and connect the screwdriver to the first channel and the main bolt to the second channel. Then add a Play Sequence response and connect it to the event. From the Sequences panel in SimLab Composer, drag and drop the driver clockwise onto the Training Builder view and attach it to the Play Sequence response and set the loop to false so that the sequence would run only once. Add a Sequence Ended event and attach the screwdriver sequence to it. Add a Change Grabbable State response and connect it to the Sequence Ended event. Then add a Scene Node input and attach the main bolt to it. What this chain would do is once the screwdriver intersects with the main bolt, it would play the screwdriver sequence rotating it to the right in a motion similar to that of a bolt tightening. And once the animation ends, the grabbable state of the bolt would become disabled, and the main bolt becomes locked in its place. The next step is placing the cover, so select the cover from the 3D scene and attach it to a scene node input in the Training Builder. Add a Change Grabbable State response and connect it to the Sequence Ended event. And connect the cover scene node to it and set its state to true. To set the cover in place, create a Node-Entered-Node event and connect the cover's scene node to its first channel. Then select the chassis of the pump and connect it as a scene node input to the second channel of the event node. Add an Apply Scene State response and connect it to the event, and attach the cover place scene state to it. You can create a change grabbable state response to disable the cover's grabbable state and connect it to the event. Or you can delay this step too after installing the 4 bolts holding the cover. Run the viewer to test out the experience. The last step in the training is the placement and tightening of the 4 bolts holding the cover. There are 2 ways to carry this out. We can either enable the grabbing of the bolts one after the other, forcing the user to follow a certain order of placing the bolts, or we can enable the grabbing for all the bolts at the same time, where the user can choose any bolt and be able to place it. For the sake of variation and breaking the sequential chain of the training, we are going to use the second method, where the user has the ability to place the bolts in the order he desires. To do so, create a change grabbable state response and connect it to the cover placement event. Add bolt 1 as an input for the response. Then select both the input node and the response and press Ctrl and C, then Ctrl and V on your keyboard to duplicate it. In the Duplicate Input node, change the attached object to bolt 2. Duplicate both nodes 2 more times, and set the input scene to be bolt 3 and bolt 4. Now attach the duplicated responses to the same event we created recently. Space the created nodes out a bit to have enough area to accommodate the soon-to-be-added nodes. Create a node-entered-node event and connect bolt 1 scene node to its first channel and the pump's chassis to the second channel. Add an Apply Scene State response and connect it to the event. Then attach the bolt 1 placed scene state to it. Now select the event and the response as well as both the scene node and scene state inputs, and press Ctrl and C, then Ctrl and V on your keyboard to duplicate them. Place the duplicated nodes near the first duplicated response and attach the input node to the event's first channel. Duplicate the same nodes again and attach them to the third node's input. Duplicate the nodes one last time and connect them with the last bolt input. The next step is changing the attached scene state for each of the replicas to match the event they are connected to. Select the first scene state node replica and click on the Bolt 2 Place Scene State to automatically assign it. For the second replica, set the attached scene state to the Bolt 3 Placed Scene State. And for the third and last replica, attach the Bolt 4 Placed Scene State. What we now have are 4 events, each responsible for placing a bolt in its place once it intersects with the pump's chassis. Next is creating events where the screwdriver tightens each bolt to secure it. But before we begin, click on the Variables Editor icon to open the Variables Editor, then click on the Add icon. Name the first variable Bolt1 and set its initial value to removed. Create 3 more variables, 1 for each bolt. We will explain the use for those variables a bit later, but once you have created those variables, close the Variables Editor window. Since the nodes are beginning to pile up and clutter the view a bit, let us create an additional clean view by pressing the Add button next to the name of the current open tab. Name the new tab Bolt Tightening, since this is where we are going to add the events related to bolt tightening. Create a Node Entered Node event and attach the screwdriver to the first channel. Then select the first bolt and attach it to the second channel of the event. Create a Change Grabbable State response and attach it to the event, and set its input to be the Bolt1 scene node. Add a Play Sequence response to the event and attach the screwdriver clockwise animation sequence to it. Add another Play Sequence response to the event and attach the Bolt1 animation sequence as its source. Now add a Change Variable Value response and connect it to the event. Make sure that the Bolt1 variable is selected in the response, and in the field value to set field type Tight. The initial value for the Bolt1 variable is removed, and once the event occurs, the value would change to Tight. You have the option to connect the variable to the response node through a variable input node instead of selecting the variable from the response's built-in variables list. Select the whole network of nodes created and duplicate them by pressing Ctrl and C, then Ctrl and V on your keyboard. We are going to do this 3 times to end up with 4 networks, 1 for each bolt. Now we modify each node to match the bolt aimed to be handled by it. From the first copy of the network, select the input Bolt1 and change it to Bolt2. Also change the animation sequence Bolt1 to the animation sequence Bolt2. Same goes for the variable. Change it from Bolt1 to Bolt2. Follow the same steps and change the nodes in the third network to the nodes related to Bolt3. And finally, modify the last network to have the input, animation sequence, and variable of Bolt4. What we have created is an event system that would set up a variable to tight whenever its corresponding bolt is tightened by the screwdriver. And as a finish up for the training, we need an event to occur only when the 4 variables are set to tight. Let's first create the final event that notifies the trainee that he completed his training. I have a plane here that has a texture on it with the message "Congratulations," and we need it to appear using scene states once all the bolts are tightened. let us first create a scene state for it. From the Scene State menu, select Capture and toggle off all the attributes except for the Visibility attribute. Then click on Capture from Selection and close the Scene State's creation window. Then select the message from the object tree and press H on your keyboard to hide it. Now, once the scene state is applied, the message would appear. So let's proceed by committing the message into the Training Builder's event system. Click on the Variable equals String Boolean node. This node monitors a variable and detects any change in its value and responds accordingly. So we are going to use it to detect the change in the bolts variable when they are changed from removed to tight. Connect the Boolean node to the variable named bolt1, and in the value field type in tight. Duplicate the node and connect it to each of the 4 variables while making sure that the value in the field is set to tight. Add the Boolean node named AND connect the variable equals string node for bolt1 in its first channel, and the variable equals string node for bolt2 in its second channel. The AND node only triggers if both of its channels have the same value. So, for example, if the variable bolt1 is set to tight and the variable bolt2 is not, then the AND Boolean node would not forward and execute to a response. Duplicate the AND node and connect the 2 remaining variable equals string nodes to it. Duplicate it one last time and connect the outputs to the previous created AND nodes as the inputs for the last AND node. The design of this network dictates that all the variables' value have to be set to tight in order for the last AND node to carry out a response. Add an Apply Scene State response and connect it to the OnTrue channel of the AND node. Then attach the scene state we created to show the Congratulations message to the response. Make sure that all the connections and nodes are in check, then run the viewer to see the final result. The Training Builder in SimLab Composer allows designers to create intricate and sophisticated VR experiences with ease and simplicity. The use of nodes and connections in place of complicated scripts and codes enables trainers with no technical background to come up with the most fascinating of virtual reality experiences quickly and effortlessly.